In this lecture, we define a function. The function is a fundamental concept in mathematics. We'll talk about the definition and the domain of functions, and we'll look at defining functions as equations involving real numbers. A function f from x to y assigns to each element of the set x an element of y. We can picture a function as a machine. Here with this machine, we drop in x values and the output will be y values. So from the top of the function, we input x, the function does some type of computation, and we get output f of x. The set x of inputs is called the domain of the function. The set y of all conceivable outputs is the codomain. The set of all true outputs is the range. So the range of a function, the true outputs, is a subset of the codomain y. The most important criteria for a function is this. A function must assign to each input a unique output. We cannot allow several different outputs to correspond to an input. Let's look at an example from Wikipedia of a function from a set x to a set y. In this case, my function is going to map 1 to the letter D, the number 2 to the letter C, and the number 3 to the letter C. Note that each element of x has a unique output in y. However, the map below is not a function. In the map below, some items in x are not mapped anywhere, but worse, the number 2 has two outputs, both B and C. Functions are not allowed to change a single input into several outputs. You are now allowed to stick in the number 2 here and get out two different outputs, B and C. Functions occur naturally throughout our world, certainly in the sciences. When we pull out an attribute of an object, we're essentially creating a function. For example, let's look at the set x below. The set x below has 4 polygons with different colors. We could ask, what's the color of a polygon? When we ask that question, we are creating a function. We are mapping polygons to colors. Functions occur throughout our modern technological society. The U.S. Social Security number is a function, let's call it SSN, that maps U.S. citizens to 9-digit numbers. At Sam Houston State University, all students and staff are assigned a SAM-ID. This is a function, SAM-ID, mapping students and staff to 9-digit numbers. For example, the SAM-ID maps me, Ken W. Smith, to the number 000354765. If you're a student on this campus, you've learned to memorize that 9-digit number. This function exists so that data about students and staff, classes, grades, wages, and so on, can be kept in a computer database tracked by a single number, the SAM-ID. Although functions in science are often defined by equations, they do not have to be. The SAM-ID function we just discussed is not defined by an equation. In its most general form, a function is a collection of ordered pairs satisfying certain requirements. For example, consider the set D, which has in it the number 1, the letters A, B, and Z, and the word orange. And the set C, which has in it the letters R, S, T, U, and V, and the number 1000. We could create a function f from D to C just by assigning to each member of D a member of C and creating this table. On the left is the inputs, the elements from D, 1A, B, Z, orange, and on the right are some outputs. This is a function. The domain is the elements of D. Each element of D has a unique output. We can often define a function in this way by a table or a list of ordered pairs. If we listed the ordered pairs here, they would simply be the rows of the table. The ordered pair 1, R means that 1 is mapped to R. The ordered pair A, S means that A is mapped to S, and so on. These ordered pairs are simply the entries, the rows in the table. So here we have a tabular form for a function and a listing of a function as a collection of ordered pairs. Let's do some exercises. Let's consider a function with the domain D as given, the integers from -2 to 2, and the codomain will be the collection of real numbers. The function is going to be defined by a formula. Let's call the function g, and g of x is x squared. We will display the function g in tabular form. We'll display the function g as a set of ordered pairs, and then we'll give the range of the function g. These are typical worksheet assignments or quiz problems. First, as a table, we can write out the function g this way. The inputs x are in the column on the left, and the outputs are on the right. Minus 2, when you square it, gives out 4. Minus 1, when squared, gives out 1, and so on. As a collection of ordered pairs, we create our ordered pairs like minus 2, 4, and minus 1, 1, just coming from the rows of the table. 0, 0, 1, 1, 2, 4. 2, 4 means that the input 2 gives the output 4. What's the range? It's the collection of true outputs. Only 0, 1, and 4 occur as true outputs of the function g. Here's another example. Again, off of Wikipedia, the function we looked at earlier. Let's write this function in both tabular form and as a set of ordered pairs. As a table, there it is. 1's mapped to D, 2's mapped to C, and 3's mapped to C. As ordered pairs, 1, D, that ordered pair means that 1 is mapped to D. The next ordered pair, 2, C, means that 2 is mapped to C, and then there's the ordered pair 3, C. In the next lecture, we will examine functions defined by equations.